This video is going to be a quick video on how to physically find an inverse. An inverse, just like a determinant, is an operation that we do with matrices, and an inverse is how we will solve matrices the majority of the time. Inverse is going to lead us on how to use our calculator, which is going to hopefully be a really quick way for you to be able to solve different types of things along the way. We're going to use these for finding equations of quadratics in this unit. We're using them to solve systems of equations. We can use them to find equations for story problems. There's lots of different uses for inverses, but again, once we know how to do it by hand, we're going to have the opportunity to be able to go to our calculator to do it. So to begin with, we are just going to go through the methodical process of how to find the inverse. In the next video, it's going to be how do you actually use inverses to solve matrices. So to start, the inverse of a matrix, we only can find the inverse of a square matrix, and the only one we will actually do by hand is a 2 by 2. Normally I say, okay, we're going to do 2 by 2, then we go to 3 by 3, 4 by 4 is usually followed directly. We will not do 3 by 3s by hand. The process to 3 by 3s is so incredibly complex. If you ever have to find the inverse of a 3 by 3 matrix, you will be using your calculator for it. 2 by 2s, however, you are responsible for knowing how to calculate it and to get that specific value out. The values out, I should say. So to begin with, I have this A matrix, A, B, C, D, like we always use. Notation for an inverse is A with that superscript of a -1. In order to do this, we have to find the determinant of A, just like we always have. And it's 1 over the determinant of A. It's going to be a scalar multiplier of 1 over that number. So we are going to deal with a lot of fractions when we do inverses. Then what I do is I have this flipped around matrix. So that A matrix was A, B, C, D. It's now D, the opposite of B, the opposite of C, and A. Do you see how each of those changed? D and A flip-flop places. B and C change negations. So if it was positive, it becomes negative. If it was negative, it becomes positive. Then I just multiply them together. That's the inverse. There are 2 parts to every inverse. It's 1 over the determinant times that flipped around matrix. Don't forget the 1 over the determinant. So we're going to go through and practice a problem so you have a practice on how to calculate an inverse. So we're going to find the inverse of A. So here's my A matrix, 1, 2, -3, 6. So I want you to calculate the inverse of this. I need to find A inverse. So to start, I need to find the determinant of A. Well, 1 times 6 minus 2 times -3, which gives me 6 plus 6, so it's 12. So my determinant of A is 12. So the inverse of A is 1 over 12 times this flipped around matrix. A and D switch places, so 1 and 6 flip places. 2 and -3 stay in the same spot, but they change negations, so it's -2, +3. This is multiplication. It is a scalar multiplier. So the very last thing I'm going to do is multiply it through. So 1/12 times 6 is 6/12, -2/12, 3/12, and 1/12. The inverse of a matrix is another matrix. We also have fractions that can simplify. In this case, 3 of the 4 fractions simplify down further. However, what you will also notice is all 4 of them will have different denominators. What we are going to use inverses for, we do not want to simplify the fractions if we can help it, unless it comes out to nice integer values. These are all going to be fractions still. Normally I say simplify, simplify, simplify. This is the one time I would not recommend it. Okay, so that's how you calculate an inverse. That's the inverse matrix. So what I want you to see is what happens now. I have a matrix A, and I have its inverse. What happens if I were to multiply the 2 together? So that takes me to this page here. I want to find the inverse of A times A. First off, can I multiply those 2 together? 2 by 2 matrix times 2 by 2 matrix. The inside's the same. The outside is the result. So yes, I am. It's going to be a 2 by 2 as a result. So what I have to do is I'm going to have to take this and multiply together my row by my column. So I have 6/12, -2/12, 3/12, and 1/12. That's my inverse. That's first, so that's on the left-hand side. I'm going to multiply by my A matrix. 1, 2, -3, 6. And you'll see why in a little bit why I didn't simplify those fractions. So I go through the process and I do entire rows by entire columns. This is why we do multiplication of matrices. If you do not remember this, pause this video, go back and look at multiplication, because what we're going to work with the fractions, is much more difficult than the types of multiplications we did before. So now when I do this, I go through my multiplication process. So I get 6/12 times 1 plus -2/12 times -3. So that's my top left element. Top right, row by column, 6/12 times 2 plus -2/12 times 6. Bottom, 3/12 times 1 plus 1/12 times -3, and 3/12 times 2 plus 1/12 times 6. Okay, now I have to do multiplication and I have to add fractions. I already have common denominators because of all the fractions and how they were. So because of that, that's why I don't simplify the fractions if I don't have to. So now I go through, I have 6/12 plus 6/12. And then the second one, I have 12/12 plus a -12/12. Bottom right, 3/12 plus a -3/12. Bottom right, 6/12 plus 6/12. Which gives me 12/12, which of course is 1, 0, 0, 1. And that's the identity matrix. If you think about multiplying, if I multiply anything by 1, I get itself. That's a multiplicative identity. If I add 0 to anything, I get what I started with. That's the additive identity. If I multiply any matrix that's going to be multiplied by a 2 by 2 matrix, I get itself. So if I take 1, 0, 0, 1 and I multiply it by 2, 3, 4, 5, my result is 2, 3, 4, 5. If I had a 3 by 3 identity, be 1, 0, 0, 0, 1, 0, 0, 0, 1. I can multiply that by anything I want. Any 3 by 3 matrix I want. And I'm going to get that initial 3 by 3 matrix out that I started with. So 1's down the diagonal, 0's everywhere else, is that identity matrix, which will be useful when we actually start solving our systems of equations. So inverses, plain and simple, how do you calculate them? Take 1 over the determinant of the matrix, multiply it by that flipped around matrix, keeping in mind A and D switch spots, B and C change negations. The next video we're going to work on, you are going to actually calculate, use the inverse to calculate your intersections.